All right, so we are also live on YouTube, and we'll be recording this. So for this, I'm going to YouTube so I don't hear myself. All right. So let's go ahead and get started. So week 2 is going to be very interesting. We're going to talk about abstraction. Last week, we talked about computational thinking, and we talked about 4 things, 4 elements, the important elements of computational thinking, right? And this week, we are going to be focusing on abstraction. Abstraction is super important aspect. So before we get started, again, mute your microphones if you're not talking. And if you have any problems or anything, feel free to unmute yourself and tell me if I'm super pixelated, or if you're not able to hear me properly. You can always open your chat window and talk to me. All right. And last week, it looks like a few of you did yours. I also reviewed them, and I gave my review as well. You all did a fantastic job. You all put your thoughts down, and I gave my responses as well on this one. So yeah, you can open up your class like you did last time, and let's see, view submissions. Yeah, I have received responses from all of you. I got last two, Krishnan and Komarina. You sent me these, I think, last when I checked. So I can get back to you as soon as I can after this class. But yeah, Saurish, Maithli, Abhav, Mahesh, you all did fantastic job. Good job. So this week also, I'm going to give another type of assignment, which I'm going to talk about it. All right. So yeah, week 2, we are going to understand the concept of abstraction. And also what all the, whenever we talk about abstraction, layers of abstraction, what is the highest level of abstraction, what is the lowest level of abstraction. I'm going to talk about that as well. We're going to talk about variables and functions. So abstraction is all about variables and functions. So we're going to talk about that, and also we'll practice. We'll actually give you some problem sets to solve, and I can let you abstract the logic from the problem set. And couple of days back, I talked to because he's a science teacher. He's a high school science teacher out of South Texas, and I asked him about computational thinking usage in science, and I'm going to play a little video clip. Go ahead and watch it, and if you have any questions, we can talk about it. Our guest speaker here is Mr. Efren Rodriguez. He's a high school science teacher from South Texas ISD, and he actually taught computer science, physics, as well as chemistry. So he's well versed with a lot of science topics, and he's also a Google expert as well. He provides a lot of assistance to a lot of teachers in Texas and around the world. So thanks for joining us. So let's talk about computational thinking. So like I was explaining you, we are actually talking about computational thinking, and we are also talking about computational thinking in terms of how it can be applied across all curriculums. So so as a science teacher, I'm curious to take your take as well on how we can potentially apply some of these computational thinking elements like abstraction, decomposition, pattern recognition, and learn concepts from science, learn concepts from physics or chemistry, in a better way, right? So can we actually use these and learn better concepts in chemistry? So what's your general take on that?
Well, I think especially like you mentioned for chemistry, that's my main subject, and I think it really applies sciences, especially when you're talking about, for example, the atom making compounds and so on. We really can't see those things, right? So the whole thing is abstract to begin with. Sure. But when you start looking at it within the computational thinking part is, okay, well, how could we look at it when we're breaking things down? And again, we can look at problems that we do in physics. We can do problems that we're going to do in chemistry, right? Obviously, in computer science, we always think about, how we're going to break this apart. How are we going to work with it, right? What sequence are we going to go through, right, to get that algorithm that we've got? So let's just start with maybe writing a chemical formula, okay, right? To come up with a chemical equation. So if they give us some type of word equation that we have to figure out a chemical reaction for, right? We got the reactants, we got the products. How do we get the symbols for those, right? And this is where I would think about, first off, the abstraction part. Like, well, okay, let's say we're going to make sodium chloride. Well, what do we know about sodium chloride? Well, it's made out of two elements. You've got your sodium and your chlorine. So how are these coming together? So we really have to break this down, right? We want to decompose it, right? Sure. Where are these things coming from? So we know, and again, this is all leading up from the beginning of when we start learning chemistry in the classroom, and chemical equations is one of the towards the end that we end up with. So we know, for example, sodium is a metal, right? And chlorine is a nonmetal. Well, where are they located on the periodic table, right? So this is where we start getting to pattern recognition. Right. Okay, well, we know, okay, sodium is in the first group of elements, right? And our chlorine is in group 7A or 17, depending on how you're looking at your periodic table. Okay, so they're in those individual groups. Well, what do we know about those groups? So, for example, sodium, right? It's in the first group, so we know that normally the metals in that group take on a positive one charge. And chlorine in the non-metal group of the halogens takes on a negative one charge. How did they get those charges? Well, that's where the abstraction comes in, right? Students start recognizing the patterns of positive one, negative one. We're not looking back at, well, how are the electrons set up there, right? What was our Lewis dot structure? What ended up giving us a positive one, negative one, right? So we don't have to, that's where the abstraction, at least I look at it as the abstraction. We don't have to look at all those other things. We've already recognized that based on all those other things, we don't have to go through all those things to remember positive one, negative one, right? And then finally, our algorithm for that is we start putting these opposite charges together because, again, opposites attract. Now, how many of each do we need? Right? Well, we have to end up where we end up canceling the charges. So sodium is a positive one, chlorine is a negative one. So we just need one of each to end up canceling, right? So we end up with what we call a formula unit for our ionic compound. So that's the way I look at how we actually use computational thinking within chemistry. And again, this was just to solve a problem. How do we break it apart? How do we decompose it? And looking at all those things.
Yeah, thanks, Efren. I think that's a very nice way to put computational thinking use in terms of how you would understand a concept, right? So basically, the concept is here understanding how a chemical equation can be put together, or how you can when you take a chemical equation, how you can break it into or decompose into multiple things like metal and try to identify a pattern, right? So maybe we can take like multiple equations, similar equations, and see if we can decompose it in a way and recognize the pattern between these similar equations. So would you think I guess we can say we can learn the concept of decomposing this equation better by applying these computational thinking elements like abstraction,
Right.
decomposition, and everything, right?
Right.
So
So, like when you do, for example, when you're shooting something, right, for projectile problems in physics, right? Sometimes people just try to put, okay, here's this one equation that solves everything, but why does that work? Right? So that's why we can actually decompose it into the different little sections on what is happening to, for example, if it's a cannonball that's being shot out, right? What happens at the topmost part? Right? What happens to your y velocity, your x
okay,
velocity, and so on?
are you all following what he's saying there?
Yeah.
Okay, I'm going to share this with you so you can watch the rest of the video. So he actually talked about a good example in chemistry, a good example in physics on how we can actually use this computational thinking. Any questions? Yeah, if you have any more questions, you can let me know. I can answer them either now or later. Yeah, like you were saying, chemistry is basically who all learned about periodic table so far. I know we got sixth
Me.
graders, seventh graders. I at least heard one voice there. Good. Or you eighth graders, ninth graders?
Seventh grade.
Six.
Seventh grade. So seventh grade, they talked about periodic table for you? Yes?
I think you learn it in sixth too.
Okay. And you know what metals and non-metals are, right?
Yeah.
Okay.
Yes.
So yeah, how you group all the metals together, or how you group all the non-metals together, right? So they're using a certain pattern to recognize metals and non-metals, right? I think we also talked about the same thing last week as well. All right, let's talk about abstraction. So what do y'all know about abstraction by now? You can open up and talk. The process of identifying necessary elements that are needed to solve a problem, right? Taking out unnecessary stuff, right? So what is the most important thing? What is the absolute necessary thing that we need to solve a problem? That is basically abstraction. It's the process of abstracting a logic, a certain elements that you need to solve a problem. That is abstraction, right? Well, agree? Yes or no?
Yes.
So when you're traveling from point A to B, you can say I'm going from point A to B and you're done, right? Or you can say I'm actually stopping somewhere. You can actually make it in a way, the path, make it in a way that you can put more details into the path from A to B. Okay? And you can increase your granularity of details when you're going from A to B. Okay, so when you are moving from top to bottom, you are increasing the level of abstraction. Okay, so we call the top one as the highest level of abstraction and the bottom one as the lowest level of abstraction. Okay, so when you talk about the lowest level of abstraction, means you're putting more details into the path. Okay, into the path. Think of this path as a path of problem solving. Okay, you follow me? I'm going to give you a real world example so you can understand better. So I thought of this trip that I took from traveling from India to US. Okay, so let me present this. Okay, you see the slide, right? Now, so I started on Thursday morning at 8 o'clock in India, and I took a rickshaw, auto rickshaw, and I reached the shore at 9 o'clock, where I took the boat at 9 o'clock, and I reached the train station at 1 o'clock. Okay, I boarded the train at 1 o'clock, and I boarded the flight at 6 o'clock, which means I reached it at 6 o'clock, and I boarded the flight at 6 o'clock. Okay. Now, obviously, the flight journey takes a while, and after reaching USA, it was at 3 p.m. Friday, and I took a taxi again at 3 o'clock, and I reached home at 4 p.m. on Friday. Okay, this is a long path, right? You all follow?
Yes.
Yes.
Yeah.
So now, obviously, there are some assumptions here. Just don't complicate yourself. Just think that we are on the same time zone and everything. Now, if I ask you a question, let me ask you some questions here. How much time it took for me to reach the train station from the point of where I took the boat?
Oh, 4 hours.
4 hours?
4 hours.
Okay.
4 hours.
Okay, so let me ask you another question. How much time it took for me to reach home on Friday since I took the taxi?
1 hour.
1 hour?
1 hour.
Huh?
Okay, so one more question. How much time it took for me to reach the train station from the very beginning?
5 hours.
5 hours.
5 hours.
Oh, 5
Okay. So when I ask you a question, you're doing what?
Abstraction.
Yeah, we'll get there, but you're trying to solve a problem, right? How are you trying to solve the problem? When I ask you a question, for example, about the train station, how long it took for you for me to start from the starting point all the way to reach the train station. You were not thinking about the other details that we have, right? You're not thinking about the flight I took or the taxi I took, right? You're only focusing on what?
The
time
boat
Train.
of
and the train and the auto rickshaw.
Okay, you got more
the
details.
auto rickshaw and the train.
Just the auto rickshaw and the train, right? You
And
even
the-
eliminated the boat in between, right? You're looking at the starting time at 8 o'clock, and you're looking at the boarding time at 1 p.m., right? Those are the
Yep.
two things you're looking at. You are not looking at any other things, right?
Right.
So what are you doing then? You are eliminating the thing, solving the problem, correct? Is everyone with me?
Yes. Yes.
That is the basic concept of abstraction. You are actually, you know this, but you don't know that is what it is called. So you're only taking what's needed to solve the problem. Okay? And let me ask you another question. So I asked you 3 questions, right? When I ask you these 3 questions, did you
You type paste the Leno. He's typing.
okay, so is anyone typing an answer here? All right, let's get back. So there are 3 questions I asked. Did you use the same method to solve the problem, or 3 different methods?
Same. I use the same.
They are the same.
It was all subtraction or addition.
Okay. So can you open up tell me what 2 things that you wanted to solve these 3 questions I asked. I asked 3 questions, right? So in these 3 questions I asked you, you used only 2 things to solve the problems. What are the 2 things that you used? The 2 common things.
The time and which.
Just put it in the chat.
Okay.
Let's just give opportunity to everyone to. time and day, time and the thing. Anybody? Sahar is saying time and date. What time and date? Okay, so let me ask you the same question. Maybe I'll take like one of the questions that I asked, one of the 3 questions I asked, and let me repeat again. How much time, I'm asking a question on how much time it took for you to reach the train station from the point you started at home. Starting time and ending time, that's it. That's all you needed, right? The starting time and ending time. You all agree?
Yes.
Yep.
Starting time and ending time is the only 2 things that you needed to solve the problem. And obviously, you need to know how to, okay, given that we have starting time and ending time, you need to know how to arrive at the duration. Correct?
Yeah.
So that is called the method. So these 2 things, or they are called the variables. Okay? So when we say variable, these are the variables. In the context of abstraction, the starting time and ending time, those are called the variables. Got it? And we can ask any more questions. Given this scenario, you can actually come up with more examples or more problem sets. Isn't it the duration the variable? That's a good question. That's no, the answer is no. Anybody knows why? Because you already know what the start and end time is. Yes. The duration derives from the starting time and ending time, right? It actually derived. So the variable is the most abstract element. Okay, that's called variable. So duration is not variable. It's actually it's called something called a function. It's not even a function. It's called dependent variable. Okay, so the output of start and end time, when you put it in a function, that's where you get duration. Okay. Above, are you clear? All right. Yeah, we'll get into more examples so you understand this better. So think of x as variable. In this case, we have 2 x's, right? So one x is start, another x is end. Okay. So when you put it in this mixture or whatever processing unit, or I'm just showing this as a filter. This filter could be anything. You know, it could be a computer. It could be you, right? This is a method. So we are passing this in and we are getting an output. Okay. So in this case, the duration is actually f of x. We call f of x. F of x is the output. X is the input and f of x is the output. Okay. And in between, what's happening is the magic, right? It's where this is where the processing is happening. This is very fundamental to our universe, you can say. X and f of x. This is pretty fundamental. Has anybody learned about f of x functions in your mathematics class?
Yep.
You got 7th grade, 8th graders out there?
Yes.
Pranav learned it. Yes. Can anybody talk about what you know about function? That's okay. Anybody can talk. That's fine. It looks like, so which grade are you all in? Whoever said yes. 8th grade?
9th.
9th grade? 7th grade, Maithili? Pranav is in 6th grade. He learned about, that's cool. About. So yeah. Yeah, this is pretty fundamental. Very to understand this because again, computer science, it actually came from mathematics. Speaker 5th. Okay. So when you are when you are using some variables, right? So X is a variable. So when you are getting into this computing, a processing unit, it is actually giving you an output. Okay, so this method, you can actually write your own method. For example, in your head, you did the math, right? Yeah, I gave you the start time and end time. You said you gave me the answer. So this whole box is you did the math. And this can be a computer also. You can put this in a computer and the computer can give you an answer. Okay, or a robot can do the same thing. So however, what is the important thing here? Once you know what is X, to get the output, what do you need? In between, what happens?
You need a certain way to take and put that X into that way and get a certain output.
Function. Yep, exactly. A certain way is nothing but the function. A certain way is nothing but the definition of the function. Okay. So this can be as basic as this, or this can be as complex as this. Okay. So way to get something to another place, exactly. So that way you're defining that way. So if you are super smart, you can take the super short, efficient way. On the other hand, you can take a longer way to do that. It may not be efficient as well. Okay. So just you not memorize it, but definitely understand this. Focus on this. This is pretty basic. So now we're going to do some experimenting with the variables. I'm going to show you this concept in a Dino. So Dino is a program that we wrote, and I'm going to do this to exemplify this concept. Were you all able to get into Dinos?
Yes.
Okay. So
Yes.
if you are all on Dino's homepage, at least you can actually watch me do this. If you don't have computer or if you don't have access, that's fine too. You can just watch me to do this. So this is a writing pad, okay, where you all do you all know Microsoft Word or Google Doc or any other? Did you all type in the computer?
Yeah.
Before?
Yes.
Okay. So I'm going to type in something here. I'm putting a title here. Now, let me show you an example here. Can you all see me? I'm going to type in something, okay? So Bob bought 2 oranges and gave it to Tom, okay? Now, Tom asked Bob to add 2 more oranges. So Bob gave Tom a total of 4 oranges. You with me? Yes, okay. So now, so tell me something. So what are the Bob bought 2 oranges and gave it to Tom, and Tom asked Bob to add 2 more oranges, and Bob gave 4 oranges in total. So what variables can you think of in this paragraph I wrote here?
Total
Just imagine.
oranges.
Just type, imagine and type in this box, the chat box. I heard oranges is the variable. That's okay. Anybody can write anything. I'm not saying that. I mean, there can be many more. 4 oranges. Bob asking more. So let me ask you something. Number of oranges. Lakshmi said like the number of oranges. Suhas is saying Bob asking more. So Bob asking for more. Is that the variable? Is what you're thinking, Suhas? You got 4.
Yes.
Okay. So Krishnan is saying the amount of oranges before Tom asked for more. The is a Akshay, are you saying the is a variable? The oranges. Okay. Number of oranges Tom asked for. So variable can be anything, right? What is a variable that changes, right? So, okay. So we can make the number of oranges as a variable, let's say. Okay. So Abhav is saying number of oranges. So Abhav, can you tell me if number of oranges is a variable, which is 2 here, right? So can you replace with something else?
You can use like O for like oranges.
You can pick what? You can pick 4 for oranges?
No, you can use like the letter O for like the variable.
Oh, okay. Yes. So instead of, oh, you're saying O, letter O like this. So which means it could be 2 or it could be 4 is what you're saying, correct?
Yeah.
So the number of oranges could be 2 here or 4 here, right? So let's say if I use 4 oranges instead of 2, what happens?
Then the number of oranges that Tom asked would be 0, so it would just stay 4.
Okay, but how about, so you said that, but how about if I want to keep this 2 more oranges and keep this 2 plus 4 plus 2, 6 oranges?
Oh yeah,
Can I do that?
so then the total would be 6 oranges.
The total would be 6 oranges, right? So I
Yes.
can argue that this is one variable, right? And is this a variable or not? This is not a
Yes.
variable
Which one?
because this is depending on this one, correct?
Yes.
Because if I change this, this is also changing. You all with me?
Yeah.
Yeah.
Okay, so Krishnan is saying no, it is dependent on the other 2. I think it's Ananya, right? No, it is dependent on the other 2. That's correct. So this is not a variable because it is dependent on this and this. So now let me show you. Okay, so are there any other variables? How about it's not Bob? How about I make this Abhav instead? Or instead of Tom, I can make it Pranav. Right? That is a variable too. Correct?
Yes.
Yeah.
The people are also a variable, yes. So it's important to note that the total is f of x, correct? Exactly. So it's important to note that what is the problem that you're trying to solve, right? That you have to keep that in mind also, right? If you're after solving the total number of oranges, then you pick the variable accordingly. You follow me?
Yes.
Because you can make every letter, every word a variable, right? I can say Bart 4 oranges. How about instead of Bart, I can say Bob will buy 4 oranges, right? While instead of using past tense, I can use future tense. Correct? Everything instead of oranges, why can't oranges be a variable? Somebody, you all said oranges, so it could be bananas, right?
Yes.
Yes.
So instead of gave, I can say sold, right? So if you're sitting in an English class, I can actually ask you to use different verbs. Instead of gave, I can ask you to change the verb into gave or sold. I can say instead of gave, I can say sold, right? So
Yes.
there can be a number of variables that you can play with. So it's important to know what you are solving. Okay, so the context is important, right? What you're trying to solve. So let's, I'm going to introduce a couple of things. So you can use inputs to replace the variables. So let's all agree that we're going to use the number of oranges as variables for this exercise, okay? At least for these two lines, all right? So I'm going to replace this 4 oranges with a variable. So I'm going to delete 4 and I'm going to say input a number, okay? So now I have a variable called number 1, okay? Now it is showing 1,000 oranges. Now instead of saying 1,000, I can change this to 10 oranges. Okay. Now let's so we used one variable here. Let's use another variable somewhere. How about I change this? Tom asked Bob to add 2 more oranges. What if they want to add 4 more oranges? Can we make this a variable too?
Yes.
Okay, let's do that. And I'm going to select this 2 and I can delete this. And now I'm going to replace this with another variable. And I'm going to pick number again. Now I have number 2. Okay. So I have 2 variables, number 1 and number 2. Now I can say instead of 2, I can say 5. Okay. Now we have number 1 and number 2. Now what else? So Bob gave a total of 6 oranges or 15 oranges now?
15.
15 oranges.
So now what we need to do, what we need to do, we need to replace this 6 somehow, right? But like Ananya was saying, we need to use a function, right? A function which uses this and this. So what would you do to come up with a total? What anybody get any guesses?
You would do number 1 plus number 2.
Number 1 plus number 2, addition, correct. So let's do that. I'm going to replace 6 with a number 1 plus number 2. So for that, delete it, and you see the functions here, down in the bottom left corner side. So I'm going to click that, and now he's saying enter the expression. Now I'll say number 1 plus number 2. You see 15 oranges? So now pick another number instead of 10.
15.
17. 17.
17. Okay. Did you do the math right? Yes. So it's 22, Srikar, right? So 20. Okay. So how about let's add 20 more oranges. Right? You see 37. Okay. So you can recognize the variables like this. Okay. So this is one layer. Do you want to add more variables? So we took care of what? We took care of the number of oranges variables, correct? And how about, do you want to try some other variables now? Do you want to change oranges to bananas maybe?
Yeah,
Or
I
do you
guess
want to change Bob to something else? Okay, so let's change oranges to bananas. Okay?
Okay.
sure.
So how many times we are using oranges here? Do you see any, do you see,
You use it 3 times.
see I'm talking about the word oranges. Just here, 3. You all agree?
Yes.
Okay, so how about we replace oranges with something else? So this is a text, right? So I'm going to replace this with a text field, okay? So watch me do this. So I'm doing a short text now. So let's replace this short text with bananas. Did I spell it right? Bananas. Okay. So what is the new variable we created?
Bananas.
Bananas. But what is the
Next one.
text one? Correct. Yeah. So Srikar, the text, yeah, B could be used for the variable, but we are using text one, okay, for the variable. Now, can we use the same variable wherever oranges is? Yes? Okay. So I'm going to replace this oranges here, and I'm typing in hash key text one. And wherever I'm seeing oranges, I'm deleting that. In hash key. This is a hash, okay? Hash is shift 3, okay? Shift 3, I'm selecting text 1. So now how many variables? So the same variable is used here, 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 3 times, right? Now,
Yes.
now let's change bananas to something else. What do you want to use instead of bananas?
Watermelon.
Grapes. I saw grapes first. Okay, you see what happened? All the 3 variables, the 3 instances of these variables got updated. You see that? And let's save this guy and let's do a preview. So now this is your output. Now we can change grapes to apples. Do you see apples getting updated?
Yes.
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 And now we can say instead of 17 apples, I can change this to 100 apples. Is the math adding up okay?
Yes.
120. So this is a text where you're seeing variables and your regular text, right? So similarly, we can change Bob and Tom also. So we have 2 different types of variables here, right? So one is a number variable, and another one is a text variable, right? If
Yes.
anybody is not following, let me know. I can explain this again. So we used one function here, right? We use one function here where it is where we're adding number 1 and number 2. Okay? You follow me?
Yes.
Similarly, there are so many other type of variables that you can play with. Okay? I'm just trying to simplify it, and I use number for you, and I used text field for you. Okay? And for simplicity, I think this is good enough. You can also use functions. So anybody has any more examples that you want me to use? I can give you a few more seconds for you. Any more examples that you want to use here?
No, thank you.
No, thank you.
Okay. So everybody wants to. Okay, I can give you another example. So let's see. Enter. Let's do some math here. Enter a number. So let's pick another variable. Okay. Let's say enter a number. Here is my number. Let's say here is my number. Okay, his number is 10. Okay. Now add another number. Another number is 2. 7. Okay, fine. And the total of these two numbers are what?
17.
17. So can anyone tell me how you can get this 17?
You add 10 to 7 or
You
7
add
to 10.
7 to 10.
What are the variables that you're seeing in this?
10 and
10
7.
and 7.
And
10 and
17.
7.
17 is a dependent variable.
17 is a dependent variable. Who's that?
Me.
Me who?
Uhas.
Okay, that's good. Yeah, 17 is a dependent variable. So maybe we can say here is the number of, yeah, I don't want to complicate this. I just wanted to keep it simple for you. So, okay, so let's add a, okay, tell me what should I do to add a variable? Anybody, what do you want to do to
You
replace the
turn
10?
them both into number variables like number 1 and number 2. And then
Okay, so how about I select a number here? Good. So now the variable is number 3. Okay, and we are adding another number. Can we replace this 7 with another variable?
yes, number 4.
Yes.
Number 4. Srikar, number 4 is correct because number 1 and 2, they're already used up here, right? We cannot use the same, use a different one. Now we have number 3 and number 4. And what should I do to replace the 17?
You have
Write it
to,
as number.
it's a function.
It's a
Number
function,
1.
yeah.
Yes, it's a function.
Hmm.
So
Function
can
2.
okay, so, and I'm going to click this functions here. Yes. So now we can say number 3 plus number 4, 2000, right? Are we good?
Yes.
Okay. So there are different types of variables. So you saw variables which are variables, not which is independent variables, and you have dependent variables. Use a function in a different function. For example, I have func1 here and function2 here. You can add these two if you want. Okay, so you can when we talked about layers of abstraction, we can actually build more functions on top of another function. You follow me? So
Yes.
let's add the number of apples with the above number. Okay, so now I can say functions. I can say func1 plus func2. You see that? Is it not working?
Yes.
So this is basically this is called you have dependent variables and you're using dependent variables inside another function. Okay. So now if we change this, oh, not yet. Okay. So the other way you can do is you can replace this number 1 plus number 2. So this is what we are doing. This is decomposing, right? We're decomposing the functions into 4 more. So now the total is 320. Get it? Now if I change this here,
Yes.
you're changing here and you're also changing function 3. Okay, so these are two dependent variables, right? Function 1 and function 3, they are two dependent variables. Okay, so now do you all know about Mad Libs?
Yes.
Okay, who knows about Mad Libs?
I do. So you ask Marina.
All right. So do you want to do Mad Lib exercise?
Sure.
Okay. So let me show you another example where you can do a Mad Lib example. Okay. So anybody wants to tell me a story? I'll just start typing the story. Just give me 3 or 4 sentences. Bob ate 5 apples. Is that what you're saying? Okay. And do what? Srikar, keep on going. He, I'll just use Bob here. Bob choke on the last one. He threw up. His friend gave him 5 more apples. Okay. Anything else? Give me 3 more. I don't want to write that. Okay, so he bought a pet parrot to keep him company. All right. So the parrot ate 3 apples. All right. Someone stole an apple. All right. How many apples does he have? So, okay, let's, this is a Mad Lib, right? So you can replace any of these names with your own. All right, let's focus here. Bob, apples. Okay, what are the variables that you are seeing here? The potential Mad Lib. What is a Mad Lib, right? Mad Lib is something where you identify a few things and you can change it with something else, correct? So what are the possible things that we can replace?
Bob,
Replace the number of apples.
stole someone.
Okay,
Number of apples. Who ate the apples? Who stole
Okay.
the apples?
Okay, let's take Bob, for example. So give me a possibility. So let's take like 3 or 4 possibilities for Bob. Instead of Bob, who else it could be?
Timmy.
Bob, Tom,
Timmy.
Tim, Dad. Okay, so now we're going to use a variable for this, okay? So for this, since you have a list of options, I'm going to use a dropdown, okay? Dropdown means you have a list of choices here. You see on my right-hand side? Okay, so you want to use Tim, you can say Logan, and John. All right, that's enough. So you got all these options, right? So now you can see all these options are here, right? Since it's a variable. Now I'm going to use this wherever Bob is. Okay, so let's delete this guy and hash key drop down 1. You see Bob anywhere? Let's see. Well, okay, I can replace he also, right? I'll say drop down 1. And his friend, instead of his friend, I'll say Tim's friend. And he bought, I'll just say here, Are we good? So now what happens when you change Tim
Oh,
to...
we have to change him also, like to keep him company, because it could have been a girl.
Yeah, that's a good point. Do we have, let's keep it simple here. So do we have girls here? All choices?
I mean, if we changed it, we could have a girl.
Right, right. We could have a girl. Yeah, we could have a Jessica too. So yeah, I don't want to, I want to keep it simple. So him or her, right? Are we good?
Yes.
Yeah. Who all knows about if condition? Yeah, not
do.
everybody knows. So typically
do.
what will happen is you will have an if condition here, right? So if it is a boy, print him, or if it is a girl, print her, right? This is where you would use if, okay? So I just want to keep it simple here. So now what about apples? Number of apples. So number of apples can be changed, right? It can be a variable now, correct?
Yes.
Now, how about we change this time, instead of using number, I'll just use a slider, 78. So I'm using a range. Range is called a different type of variable, and it's a slider. Okay, it's 18 apples, it could be 37 apples. Yeah, this could be a big number. A pie. Yeah, pie, can you make a pie apples, Srikar? For now, it's fancy. Okay, now, instead of 5, how about we use another variable instead of 5? What do you want to do for the 5?
Variable 1. I mean,
A number, a slider?
a
Let's
number.
use another number. Okay. So yeah, you can make, for example, parrot as another one, right? So a parrot another variable. You can use apples another variable. So there are so many things you can do. Cat, yeah. So now, what time is it right now? It's 4 o'clock. Okay, so I gave you an example here. Do you think at home you can create your own Madlib?
Yes. So is it going to be like homework?
Yes. So this is a classic example of abstraction where you have variables, you got dependent variables, you got functions. So this is all abstraction. Yeah, in the homework. Okay, who is the 070873? So what are you saying no for?
Pranav.
Pranav,
Yeah.
what are you saying no for?
Coding come for the week 1, so I don't know the link.
Yeah, if you have questions, let me know. Okay, so you see week 2 here. You see build your own lib, own Madlib. You can yeah, after you log in, you can open it up and you can practice. You can start writing your Madlib here. Okay, it could be anything.
Okay.
All right, try to do some Madlib example here. So just like how I showed you, do some experiments, do whatever you think that's appropriate. And if you have any questions, let me know. Okay, you can email me. We can get on a call and we can talk. Any questions now? Where is my chat window? Let's see. Okay, are we all good? Okay. All right, see you all next week. If you have any more questions, let me know, okay?
Bye.
Bye. Bye. Thank you.
All right, thanks. Bye-bye.
Thank you.
Bye.
Bye.